Good morning, 804. Welcome back. What I'm going to do this morning is a very quick remedial lesson in this video to give you a very much more simplified view of indifference curves. Okay, so first we'll talk about indifference curves, and we will plot and demonstrate preferences on that curve. I think you've already got a good sense of that. But then we'll just very quickly mention utility and see how that relates to the slope of the curve. Beyond that, we'll lay a couple budget lines over these indifference curves so that we can see how they relate one to the other vis-a-vis a budget line. And then finally, we'll take a very quick look at the relationship between income and substitution effects via these same indifference curves. So let's first draw an indifference curve that works for us.
Texture like sun lays me down. With my mind she runs throughout the night. No need to fight, never a frown with golden brown. Every time just like...
So here we have a workable indifference curve. Assume you have two goods between which you are indifferent. You could have, let's say, 1x, 6y, that is 1 of x and 6 of y, or you could have 6 of x and 1 of y, and you're indifferent between those 2 points, which gives us this curve. You could also, somewhere in between those 2 points, have, say, 2x and 3y, or 3x and 2y, and again, that's what gives us this curve. You are indifferent between good y and good x at any point along this curve. Now, the reason that we have this curve, you'll notice that at the extremes here we have 7 goods, and in the middle here we have only 6 goods. So at each coordinate here we have 3 and 2, 2 and 3. We only have 6 individual items, and out at the extremes we have, or not quite extreme, but further out on the curve we have 7. So again, you actually have more items further out on the curve. But what is actually very interesting about this, and what makes it a curve, is that your utility function is the same here as it is here. Let me just show you that very quickly. So utility function is a very simple expression. It's just u x times y. So if we were going to draw this out in a long calculus expression like I failed to do yesterday because I was trying to make it complicated and simple all at the same time, then we would need to have this function, and it would be changing over a period of a curve, and that would allow us to demonstrate change in a more complex way. But for now, all we need to know is that the utility function at this point on the curve, 1 times 6, is 6. Down here, 2 and 3, again, fewer individual items, but 2 times 3, your utility is 6. So it's equal here, 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 and so on, okay? However, let's say we draw a hypothetical budget line. So let's say you're able, theoretically, to purchase 6 or even 7, let's say, of either x or y. So forgive my sketchy, quite literally, budget line here. But let's say our budget line runs something like this. So we can see that according to our initial indifference curve, on which we're equally happy wherever, we now are seeing, of course, that our budget line crosses through 2 points of the initial one, but intercepts, again, slightly awkwardly, but is tangent to our next indifference curve up. So why are we not then, as consumers, going to be consuming at at either of these 2 points? Well, remember we mentioned the utility function on this curve is 6. Remember? Whereas here we have this coordinate where we reach a tangent point which is 4 and 4. In other words, our utility function here is 4 times 4. So 16, right? So even though we're only just touching one point of this, and it may seem like you're going to optimize here because you're getting more of the line, the fact is that the optimal point given any budget constraint, is where we reach the indifference curve at a tangent point. And again, according to non-satiation, we want to operate on the next curve up. So we now have a utility function of 16 up at this next point, which would, again, as per our indifference curve laws, would mean that we would have the same utility all the way along it as we swapped out goods one for the other. Okay? So the bottom line is we can move along an indifference curve until such point that our budget allows us to move up, and where the next indifference curve hits our budget at a tangent, then we're moving up to that line as opposed to remaining on the original. We are, if we fail to do so, we're losing utility, and our utility function is not as high as it could be. Okay? So let's get ourselves a fresh indifference curve using the same coordinates, and we will do a much simpler demonstration of marginal rate of substitution so that you can get a sense of why these curves operate as they do.
Heading west from far away, stays for a day, never a frown with golden brown.
So here we have a new chart, marginal rate of substitution, MRS, and this is an important concept in economics because essentially it gets down to the core principle, which is that in order to get more of something, you have to give up some of something else, right? Unless, of course, you have endless cash, which most of us don't. So a very important concept, and of course it relates to opportunity cost, as we've discussed before. So here we have same curve, same coordinates. This time, we can forget this actually for now. I've put actual objects on our y and x axes so that it helps you to envision this a little bit better. On the y-axis we have chocolate bars, and on the x-axis a bowl of fruit. So let's say, I don't know, these are oranges, and for Mary Beth these are Granny Smith apples, okay? Alright, so let's go to the ends of our, not the very end of course, but out to this point on our indifference curve. Here we have on the x-axis 1 and 6 on the y. So we have 1 bowl of fruit and 6 chocolate bars. What is this? Well, it simply is, a ratio of the value of one to the value of the other, given that you have so much of one and so little of the other, right? We only have one basket of fruit, and so it is of great value to us, okay? So, what would we have to get in order to give up our last remaining bowl of fruit? So you're going to ask me, okay, well, how about I take your bowl of fruit off your hands? Well, at this stage of the game, I'm so far away from having a decent amount of fruit. In fact, I'm down to one remaining unit, or at least one bowl. I'm going to need 6 chocolate bars to give up that last remaining bowl of fruit. It's just that simple, okay? That's the difference between, or rather, that's the marginal value between one and the other, given where we're at on this curve, okay? Now, let's move down here a little bit further. So let's say we have a new state of affairs, and we have, we're going to use this line here. We have now 2 bowls of fruit and 3 chocolate bars, okay? So 2x and 3y. What does this mean? Well, obviously, we're back in sort of more in the average and the optimal area of our indifference curve. So the relative value is going to be much closer to 1 to 1, right? We're not going to have such a dramatic difference as we did up here. So now where are we at? Well, I have 2 bowls of fruit, right? So, and 3 chocolate bars. So again, better balance. So in order for me to give up the remaining two bowls of fruit here, I'm going to need to get 3 more chocolate bars. Okay, so as you can see, what that would do is that would take my utility up to 6, back up to where it is here now, and where it would need to be for me to feel as though I'm staying at the same level of utility. Okay, and of course we can take that further out here. So the opposite, or the inverse down here. So we have 6 bowls of fruit and 1 chocolate bar. Same goes, only in reverse. So if you're going to ask me to give up that 1 chocolate bar, I'm going to need to get 6 bowls of fruit for it. Okay, that's how valuable a chocolate bar is at this point of the indifference curve. I have so few of them, and I have so many baskets of fruit that I'm going to need a lot more fruit in order to give up my one and only remaining chocolate bar. Okay, now remember, one property of indifference curves is that they're infinitely divisible, right? So this could go on forever. It wouldn't. You're not going to get down to the point where you're breaking off a crumb of a chocolate bar, or taking 1 Granny Smith apple, or even a fraction thereof. But on a bigger scale, it does work that way for a very long time. So if we were to go up to 7, we can see here that we're going to be below the 1 mark. So let's say that's 3/4, right? So we now have 7 bowls of fruit and 3/4 of a chocolate bar. Now, same story. We would need to get 7 bowls of fruit to give up 3/4 of a chocolate bar. Our remaining 3/4 of a chocolate bar. Okay, that carries on, and as that drops, that is the changing marginal rate at which we have to substitute to maintain our level of utility on this same curve. Okay, as I mentioned, we can, as we started doing in class the other day, but we just I got mixed up about it. We can derive this curve from scratch if we want. We can pick a point, and with a function we can figure out what the drop is each time to draw a curve. We already, though, have established a good, sensible indifference curve, so we don't need to do that. The ratio of the two, I think, is the best, most serviceable way to understand it at this point. So I'm going to go ahead and drop one final graph that will bring us to a conclusion via income and substitution effects of price changes. So here we are back to our final chart. We're going to deal now with substitution and income effects. Same basic chart as you can see. We have chocolate bars and fruit, although this appears to have changed blueberries and Granny Smith apples, let's say. We have 3 indifference curves, as you can see, and 2 budget lines. Okay, here we have a budget line tangent to this particular indifference curve and this one over here. Let's begin here. Okay, say we're going to we're going to say that we're operating at this point right here for the time being. So roughly speaking, that's 4.5 bowls of fruit to about 5 chocolate bars. Okay, that's our equilibrium point. That's our maximum utility. After all, we're at the tangent point. Let's say, for argument's sake, that the price of fruit drops. Okay, now when the price of something drops, let's say that it could be just a drop in taxes on, say, healthy fruit. Could be the inauguration of a new school lunch program that focuses on fruit consumption. Could be anything. You as an individual who consumes fruit otherwise will benefit from this in one main way, and that is in that, given that you're going to keep consuming fruit, the fact that fruit is now cheaper, functionally speaking, means that you have more disposable income. Okay? So you have more disposable income, and that means you can buy more fruit. Okay? So given this budget line and this indifference curve, well, a couple things could happen, right? The first thing that could happen is that you could just go crazy and consume a whole bunch more fruit. You could, in fact, shift your consumption of fruit way out to the right. Okay, so you would have you would have something more like 7 or 8 bowls of fruit. But you'd still be at the same number of chocolate bars. Okay, so you've only added on the x-axis and not on the y. Well, we know that's not likely to happen. Why is that? Well, because it violates the principle of what? Of non-satiation, right? We want more, and this move here would suggest that we're not getting more. Okay. Because we've given up all any additional number of chocolate bars. So leaving the shift out, let's say that we slide along the indifference curve. So as a result of lower prices for fruit, again, we're going to say that we could conceivably slide down here to point B. Okay, so that allows us to bring in more fruit, right? But because we're sliding on that indifference curve, which slopes down in a way, what also have we done? Well, we've reduced our consumption of chocolate bars. So not only have we not just kept our consumption of chocolate bars static, but assuming that hypothetically that we slide on the indifference curve, look at what has happened. So we've seen, on one hand, we've seen an income effect, meaning we're buying more fruit, but we've also seen a negative substitution effect, okay? So we, as a consequence of turning our attention to fruit, have turned away from our chocolate bar. But we don't do that as humans, right? The idea about this indifference curve system is that we slide along it until it has stopped providing us with maximum utility given a certain budget point. So what's more likely, so here we see both an income effect and a substitution effect, okay? Problem is, again, we're not likely to do that because we want to maximize our utility. So if we moved here, well, we're totally violating the principle of non-satiation, right? And in fact, ultimately, if carried to its ultimate conclusion, if we kept behaving that way, this curve would slide away and eventually cross this curve, which, as we know, isn't allowed because we're always moving, or not allowed. That's a violation of the basic properties of indifference curves, right? So what's more likely to happen, actually, is that we're going to kind of recalibrate the relationship between our fruit and our chocolate bars, right? So it's more likely, and in fact, this is the way it goes, we're going to move to point C, okay? So given that fruit is cheaper, rather than going with the same budget line and the same indifference curve, what will happen is we get, functionally anyway, a new looking budget line. Now, with a both increased consumption of fruit and increased consumption of chocolate bars. Now, because it is the price of fruit that has changed, we're gaining more marginal. We're gaining more fruit relatively than we are chocolate bars as we move. Okay, if we didn't, that would leave us with a much lower tangent point, right, on our indifference curve, and it wouldn't properly reflect the change. So we're moving up and outward, right? So what we have here is a shift up and away from our original point. Again, we could have gone this way, but we just know that we don't do that, right? So it's going to be a little bit of both, which puts us at a new point. We get a new budget line, so a new line tangent to our indifference curve, which gives us 2 different coordinates. So our income effect is seen here mostly, and our substitution effect, which would have been seen here, is seen over here. So as we increase our consumption of fruit, that puts increasing pressure on the value of chocolate bars, so we will turn and want some of them, right? But we won't get as many more chocolate bars as we do of the fruit, relatively speaking. So that's our income effect and also our substitution effect. Okay? So there you have it, folks, indifference curves. My apologies for some confusion on Thursday. I thought I could sort of wing it in a classroom setting with you guys drawing graphs at the same time. It's not as easy to do that when you haven't yourself been manipulating these kinds of numbers in a very long time. So again, my apologies. And as you can see, we've gone ahead and done it in a more simplified way. For now, leave both functions and calculus out of it for now, and just sort of understand these things graphically and visually to start with. So simple ratios I think work really well and clearly have helped demonstrate a couple of things to you. So as you can see, I've moved outside. It's getting on and it's time to get on to other things. So if you have any questions, of course come and see me or call me or email me, and we will arrange to get everything fixed up. Okay? So if I don't see you, have a good weekend. We'll see you next week.
Never